So now on to the next section of the Galaxy code architecture. In this section, I'm going to talk about the actual physical architecture of the Galaxy code, so the files and directories that are contained in the project. So what are some of the files you get when you clone down Galaxy project / Galaxy? Some of the sort of key project documents are included in this in the root directory of the Galaxy code base. So you've got your README, how to install and start Galaxy, guidelines for contributing that we already saw, the code of conduct and the license, a citation file, so a list of how to cite Galaxy, a list of contributors to Galaxy, and then some of those other documents we saw under doc source project issues and organization. The code itself is spread all over the place. Most of the Python code is in the lib directory, so it's like a monolithic Python project. There are 3 big top-level projects or top-level packages under lib. Most of the code that makes up the backend is in Galaxy. A few smaller bits of code here and there are in Galaxy X. So this is stuff used by running jobs and that sort of thing. And then the source code for the tool shed, we try to keep a little bit separate, but it's also in the lib directory. We'll talk a little bit about packages later on, but there's a separate view of the same Python code. And then the front end code is ES6 JavaScript. It's in client Galaxy scripts. That's the actual source of Galaxy. There's a ton of different scripts, front end sort of things that you might call. Run.sh has already been mentioned. It's a shell script for starting Galaxy as a standalone project. Makefile that contains sort of common development and deployment tasks like deployment stuff like checking your configuration validating your configuration, and then development stuff like regenerating the docs, for instance. Run tests is a shell script meant to be a friendly wrapper for running a lot of the different tests. The scripts directory is a directory full of more specific scripts, mostly admin-y stuff. A script to run Galaxy without a web server, a little interactive environment for exploring Galaxy data model called DV shell, and then cleanup scripts. The most important of these is PG cleanup. You can check out some of the training material around for admins to see sort of examples of how to run this. And then finally, managedb.sh is a shell script for upgrading and downgrading the Galaxy database. So when you upgrade Galaxy, you need to upgrade the database. If you do a version change, like update from one release to the next, and the script for managing that is there in the root directory. This is a talk about architecture and then Galaxy development. So testing Galaxy is a huge part of that. And again, it's sort of spread all over the place. The client-side JavaScript unit tests are a little bit easier. They're sort of mixed in with the client code for the most part. So the newest components are going to be in the newest tests with the newer style Vue.js components. The tests are right next to the source file. That makes things really nice and easy. So those are in client Galaxy scripts components. And then there's some like test suite, more like suites of tests, and those are either going to be in Mocha or QUnit currently. The newer stuff in Mocha, but we've got some legacy, older style JS QUnit tests also. In terms of Python tests for the backend, these are mixed between test and then libgalaxy test. Libgalaxy test is more like properly packaged Python tests. So there's like a base directory that's got a lot of infrastructure for running the tests, but then the actual API tests for running Galaxy are in libgalaxy test API. So there's a common sort of place to run tests from and place tests. The Selenium is like end-to-end tests with an automated web browser. That's in that libgalaxy test directory underneath the Selenium subdirectory. And then the test had just some more miscellaneous Python tests um, that don't have a proper sort of package. Integration tests, there's a huge suite of different tests, and the difference between the API tests and the integration tests are, the API tests run against a fixed known Galaxy configuration, whereas the integration tests, each test case defines its own Galaxy configuration and starts up its own Galaxy server. So you can test things like different configuration options. And then integration Selenium is a combination of like end-to-end browser testing, but on custom Galaxy configurations. And then the unit tests right now are in test unit. Hopefully, I'm going to be moving these to libgalaxy test soon, so they have proper packages. Another important file for testing is tox.ini. It's a tox entry point for linting Python and running some of these tests also, if you're familiar with the tox project. Yes, so continuous integration is a huge part of what we do with Galaxy. So here are some files that sort of get read for each pull request and executed. CI Jenkins, so these are different framework tests that get run on the using our Jenkins setup. So we run a Jenkins cluster. And so each PR runs all of these tests. Well, I mean, there's more tests that we don't run under here, but their definitions here are for Jenkins if you sort of want to configure them that way. So the ones that we're still running, I think, on Jenkins are the API tests, the framework tests, and the Selenium tests. And so these are special scripts that all sort of wrap that run test.sh file we mentioned all the way back here. But yeah, they send it the right sort of magical parameters to sort of do it reproducibly under Docker and Jenkins. We've got a bunch of tests that run in on CircleCI for each PR. These are in .circleci. We do we validate our tools. We lint the Python code. We run unit tests. All that happens on CircleCI. And then we've got some newer style sort of GitHub workflows. We run our integration suite there. We run the integration Selenium suite there. We run our toolshed tests there. And we run all the Galaxy data type converters. We run tests for those on GitHub actions. So I mentioned that lib and packages are two different views of the Python project. So let's take a couple different files here under libgalaxy. The util directory has just a bunch of various Python sort of common utilities that are used across the whole Python application. Libgalaxy model mapping contains the SQL alchemy mapping that maps, the relational database to Python objects. And libgalaxy web framework contains a bunch of frameworky web code that controllers and such use. Under lib, there are a big assortment of different directories that all are just sort of exist side by side. But we're trying to move towards packaging them properly and defining the dependencies in a more structured way. And so we have the packages view of these. And underneath packages, there's a bunch of different projects or packages, and each of them have their own Galaxy directory or whatever root directory it's representing. So for instance, this libgalaxy util init, well, underneath the util package, it's Galaxy util init. And then the mapping here is Galaxy model mapping, and this framework code is in the web package is under Galaxy web framework. And a Galaxy namespace package is used. So what a Galaxy namespace, a Python namespace package is used. And what that means is each of these packages has an init.py file underneath the Galaxy directory that basically says this is a namespace package. So many different packages may be throwing stuff into this directory. And so we publish util, we publish data, we publish web framework basically to PyPy, the Python project index. And each of these are contributing something to the Galaxy namespace. And we use symbolic links in here, like in the source tree, so that these views are synced up. So you could develop here, or you could develop this way. Um, Most people are still developing this way, and it makes sense for most things. But I would imagine as we get better at CI for these packages, and more people find more utility and more ways to use the individual packages, there'll be more development that happens on the packages. But we will see. The package structure is laid out here. Util has no other dependencies on different. I mean, all of these have different dependencies, right? And app and web apps have a huge number of dependencies. Um, but but util has no other dependencies on other Galaxy packages. Um, Object store depends only on util, and so this is we'll talk more about the object store and the different components, but this is the sort of uh, interaction level that stores data sets onto physical disk. Um, Containers is not too used, not very used or useful, but tool util is a very common um, package that gets reused in other projects. So Planemo, Pulsar, um, CWL, Reference Runner all use tool util, and so it has tools for, it has Python files for using Galaxy's dependency resolver framework, interacting with Conda and such. It has the parsing libraries for Galaxy tool files. It has Galaxy's linters for tool files, and you can see here it depends on containers and util, sort of recursively. The web stack is an interaction layer with the web frameworks like messaging and stuff. Maybe not super useful on its own. Web framework sort of extends that and adds some decorators and stuff to build Galaxy-style controllers and applications. And we'll talk a lot about this coming up. The data project here is a bunch of different things, but it's the models, it's the Galaxy data types, it's the dataset collection stuff. So it's the framework for dealing with model objects and data types. Yeah. On top of that, we've got job execution, and so this is an environment. So Pulsar will reuse job execution and everything below it to sort of handle remote metadata and stuff. And so anything dealing with what happens after a job runs, and Galaxy has to collect metadata on the project, or on tools outputs. That stuff is packaged into job execution. The authentication framework is packaged separately, could potentially be useful outside of Galaxy, though no one's using it as such yet. But just packaging this way makes sure we're managing the dependencies well and avoids circular dependencies and such. And so taking together these four plus job metrics and such sort of contribute to app. And so app is all of the components of Galaxy except for the controllers, the actual web controllers. So we mentioned that Galaxy main script earlier, the running Galaxy with a web server. Presumably, it should just have dependencies on app. This whole package concept, though, is relatively new, and so we're not yet, shipping app, and so some of these are on PyPy, and some of them we're still working towards getting them onto PyPy, but aspirational. Anyway, extending web app is web apps, which is a big package that has all of the controllers, basically, that layer that the web server talks to. Yep. And then we got the testing packages. So the test driver, the testing base only depends on tool util. So it's got some it runs tool tests and stuff. So it does depend on tool util, but it doesn't depend on app or anything. It can't create a Galaxy server to test against. And so that's what test driver does. So test driver sort of extends some of the functionality of test base, but will actually create Galaxy instances if it needs to and run them, run web servers. And so that's why it depends on web apps. And then we package up the API tests and the Selenium tests this way, and they sort of definitely depend on the test base, and then optionally depend on test driver. So they can run standalone, or they can run against an existing server. And that is some of the reasons, some of the architecture around how we package these different sub-packages and why we're doing it. And here's an example of Galaxy Tool Util. We used to have something called Galaxy Lib, which was a subset of Galaxy. I think Galaxy Tool Util is the sort of the closest thing to that right now, with a lot of the same functionality. Galaxy Tool Util was structured differently. It wasn't managed inside the project. We weren't using symlinks, and so it would constantly get out of synchronization with Galaxy. So we would develop some sort of features for Planemo and put them into Galaxy Lib, and then we'd have a manual process for synchronizing it with Galaxy, and you'd lose, information on the commits. Things would get we'd make changes in both places and such. So people were not very happy with the concept of Galaxy Lib. So that's what we're doing with this new approach to sort of decomposing Galaxy. It was also becoming a bit monolithic itself because we didn't have all these different packages. An example of some of the files in, like packages tool util, there's a setup.py, so this is boilerplate for all sort of Python projects. There's a make file for, publishing the package and building things, the sort of wrappers around setup.py. They've got their own set of requirements. They've got their own Galaxy namespace, which includes this init py, which is like the definition saying this is a package, a namespace package. Metadata, so like make file and setup.py, we try to reuse metadata in a sort of structured way so that we can duplicate a lot, so we can keep these files in sync. And so the metadata for a particular project we load from, in this case, project underscore Galaxy Tool Util.py. And so setup py will read this file from metadata. And then this tool util is what we symlink back into lib Galaxy Tool Util. And then tests will contain symlinks to the actual util tests, the unit tests that correspond to the tool util package. And that is packages and the physical structure of the files.